So our next presenter here is Mr. Joel Patton, Director of Mission Engineering from VT-ARC. He'll be presenting updates on CERC Research Task WRT-1030, Electronic Warfare Mission Engineering Analysis Framework for a Reference Architecture. With that, I turn it over to you, Joel.
Yep, thank you, Jan. And I appreciate your help and Mimi's help as well. You guys are showing extraordinarily patience, so I do appreciate that. So the bad news is I'll be doing the presentation. Dr. Moreland will not. I'll be walking through this. This is a derivative presentation from a classified program, so I'm keeping it purposely at a fairly high level, and as a result, I'm going to be talking about it in terms of some of the products and how we're actually applying it to other programs that we're currently involved in with mission engineering. So I'll walk through that with you. So the first step is we talked about a problem and a work scope. So this is largely the funding agent for this is out of OSD, acquisition and sustainment. And it was the idea of looking at kinetic and non-kinetic aspects of system development and how they could be evaluated across different services, and what could you use as a tool to evaluate those as you begin to go through the acquisition process. But it was a little more it was a little more detailed than that, or a little more complicated, because one of the other aspects of this is we're sort of, as I'm sure all of you are aware, we're in a very accelerated operational nature of things here. So the idea is, how does the acquisition process respond more quickly in this environment, and hopefully respond purposely and forcibly to address those needs. So the idea is, how do you look at, can you utilize mission engineering and integration as an approach that could deliver that mission architecture and foster, the idea of adaptable and rapid insertion of new technologies. And I'll talk about how we're doing that in other areas as well as this. So it's a capability and a demand signal that we're getting quite a bit from the DoD these days. And finally, a set of mission-derived metrics and measures that can support that acquisition process and deriving those requirements. And I'll talk about that as well. And I'll talk a little bit about how we're doing that in our testing, mission engineering support for rapid testing with the Air Force. So I'm showing you the methodology. I've broken it down to these 4 bullets, and these 4 bullets also represent our approach that we're using at Defense Acquisition University as we're developing the mission engineering, actually 3 competencies at DAU for mission engineering, and we're incorporating this approach. So it's the idea of the framework, the mission engineering, overall for electronic warfare, capability analysis, chain assessment, and framework. And I'll talk, as we walk through this program, this presentation, I'll talk a little bit about each one of those in that context. And if I don't, please raise that question at the end. I'm sure most of you have seen these things. We've kind of taken it to a little more detail. We're now talking about effects kill webs at the campaign level. We're getting quite a demand signal right now, and we're actively participating in those types of efforts, looking at measures of operational success. And again, as we walk down through those measures down to system performance, those are becoming quite a interesting approach. And so the idea is, you can imagine if I'm starting to introduce kinetic and non-kinetic effects, electronic warfare, into my mission thread, the conventional F2, T2, EA, find, fix, track, attack, assess doesn't, or engage, assess doesn't necessarily lend itself to a integrated fires, which is what we mean by non-kinetic kinetic fires. So what we're walking through is developing at a very high level this kind of a framework, which will allow us to do some technical trade-offs as we walk through that. This is an example of using a conventional, very early in the effort, we were using a conventional F2T2EA approach, but in overlaying multiple mission threads, looking at, for instance, the primary mission thread, which was destruction of enemy air defense. And what we were seeing as you overlay all of these things, immediately what happens is the non-kinetic aspects of that mission tend to take a back seat, aren't properly perhaps as well understood. Assumptions are made which may not be entirely accurate. So the idea was, how do we raise up that non-kinetic aspect without lowering the kinetic nature of a mission? And what I've done here is I've highlighted the detect, and the detect section in these missions are very, very interesting, especially at the detect side, because that's a convergence of information, sensors, and data there, where you move from many to few. And so it's important. What I've done here is, you can see I've color coded different missions. And the idea is to convey the fact that I may have subsystems operating that may actually be operating in both the kinetic and non-kinetic world, and any effects that I might apply to those systems to address one area. I have to actually address that across multiple interfaces. So those interfaces, and defining those interfaces, become extraordinarily important. And how we define those and how we understand those become critical as you start introducing new technologies into existing platforms. As you begin to retire programs, introduce new technologies, understanding those interfaces and understanding completely how that system operates and its functionality. It should be obvious to probably most of us, but when you're down in the trenches in the laboratory working on a project, it would be useful if we could provide them some tools that could explore that. So that's the idea of again, multiple missions. We're trying to understand those overlays. So what we've done is, here is a typical Dr. Moreland mission thread in gray here, and I left it in gray on purpose, where you sort of walking through that. What we've evolved to is one for integrated flyers, where we're talking about desired effects now. So we're starting to introduce lexicon, and again, we're utilizing this. One of the benefits is we build out our DAU programs or our courses. These are concepts and lexicons that are being introduced there. So we're starting to introduce the idea that you have a C4ISR and an F2T2. You're combining those together. So you have prepare and configure, surveillance, intelligence and warning, detect and track, where you're starting to raise up the functionality of these systems and understand that system might perform functions across the entire effects kill chain, as opposed to simply just focusing it on F2T2 EA, which is where traditionally you operate. So we're trying to. So this is something we've developed, and unfortunately, I can't really show you more than that. But we are evaluating this in a number of mission threads right now, and it's yielding tremendous value to us in terms of understanding how to begin to even ask questions and engage not just with the services, but the intelligence community and other communities as we move through this. Again, what we'd like to get to is this concept of mission web, where you're actually looking at multiple threads, and again, we can see this, right? The idea of feedback loops. There are going to be nonlinear relationships. We're seeing that now when we're looking at the campaign level, where you're starting to bring in coalition partners, allies. There are a number of factors that play here. And so these nonlinear relationships are critical to this. So we're not there yet. We'd like to be there. And if anybody has some ideas, I really would love to hear those. But this is kind of where we'd like to get to. In this regards, move out of this sort of two-dimensional into a three-dimensional understanding. This is where you have to go to get to where we need to be. The next step is, now we're going to talk about the government reference architecture. And I apologize, I don't have any fancy graphics like Paul had or anything, but so it's just a series of words. But and again, it's about baselining what we're trying to do in the community and laying down markers. And so we're all speaking the same language. And I want to emphasize here that we're not creating a Virginia Tech answer or a VT ARC answer. We're taking, based on the mission engineering guidelines that were published last year, and the instruction that was published the year before, we're basing this on a DoD solution. And they're owning that solution, and they're owning this process. We're purposely not developing sort of a unique solution set for that, because that won't work. At least we believe it won't work. So here's an architectural framework. Again, as you can read, I'm not going to reiterate the slide to you, but again, what you're trying to do is baseline requirements on an architectural framework. And I'll show you how we're doing that now in a very limited case, but it really is helping us get our arms around what do we mean by that. And there's been a lot of work on this out there, and we're aware of all of it, and we're utilizing it as much as we can. So this is when we talk about this, we're looking at the Zachman framework, we're looking at TOGAF, we're starting, our starting place is, IEEE, the ISO framework. We're building this out now. Obviously, I can't show you those results, but in an unclassified form, I can certainly show you the approach and the methodologies that we're utilizing and how we're rolling this up. And again, it's the idea at an acquisition level to be able to compare mission engineering solutions. And this part of this is what we're doing for the Air Force. And we're in discussions with the Army now to have a similar discussion. That is, as each service proposes their mission engineering solutions or their technologies in this context, that we're talking the same language, that we're sharing the same information from an acquisition perspective. And again, it's the idea is it facilitates that analysis of candidate standards for interoperability, portability, reusability, extended. All the abilities are listed there. And those are critical to what we're doing. But more importantly, and I'm sure the military industrial complex doesn't like this, but we're trying to make this a very vendor technology agnostic model. So again, we don't want to give them a solution where we're going to force you to come back to us for all your modeling needs. We want to create that approach and give that to them and let that evolve. And I think that's a very important, you might say open architecture, but I think we wanted to be very specific on what we were talking about and who we were talking about there. In that regards. This is I believe my last slide, but I wanted to show you, this is just a synopsis, a snapshot of where we're at today and all the things we're doing. We're at Virginia Tech, we're at a bow wave of mission engineering efforts right now. You can see up in the upper right-hand corner, I'm really excited about the digital engineering and cyber resilience efforts that are going on. I see a tremendous amount of synergy there with mission engineering. I'm very excited with Dr. Beeling's work and what he's doing there. And if I can ever nail him to the floor long enough, I'd love the ability to work on that more. I think there's a huge opportunity there. As I said, we're building out three separate competencies there for mission engineering at DAU. The presentation I just talked to you about is that integrated fires mission thread. We're continuing that on in terms of a reference architecture. Down below the line on the RDT&E side, we're applying mission engineering to 5G smart warehouse. We have a fairly large effort with the Marine Corps in Albany, Georgia, the Marine Corps warehouse, where we're using reference architecture approach at a very high level to begin to gain some traction on how enhancements and applications can play in the mission of the warehouse, which is to enable the warfighter and help them align those processes. Command and control is critical in that area. We are looking at the Air Force AFRL. They're bringing out technologies. They're asking us to assess military utility of those technologies, and we're doing that using mission engineering. We're looking at different mission threads, and we're providing them actually system performance requirements down to them to allow them to go ahead and take that technology off the shelf and bring it to the next level. Well, how do you design it? What are my trade-offs? in that regards. We're working with DARPA on a simulation environment that they're developing, where mission engineering will be the front end of that and help inform operational concepts, and using mission engineering to develop those measures of effectiveness, success, and performance that can then influence those and allow a rapid transition of technologies developed there. And lastly, Air Force Futures Rapid Testing, where they're bringing us technologies and they're asking us to look at helping define testing criteria, both in terms of what is that testing criteria, and then what is the priority of that testing criteria. And we're using mission engineering to develop those results for them. And we're working very closely with Air Force Futures to do that. And again, what we're seeing is the synergy between model-based systems engineering, digital engineering, and mission engineering, especially in the testing and validation piece. This is where this becomes crucial in that area. And also at the warehouse, smart warehouse, model-based systems engineering and that interface, letting mission engineering starting to develop those requirements and those boundaries and those measures, letting digital engineering take that on and then take that and synthesize it and allow model-based systems engineering to deliver those solutions to you. And then lastly, maybe a shameless plug, but we are going to start offering a Virginia Tech Mission Engineering Certificate in the master's program in the Industrial Systems Engineering Department at Virginia Tech. So we're quite excited about that as well. And I believe that is my last slide. So I went quickly. I always believe less is more, because I was sort of hoping, I know it's the last session, so I know I'm probably standing between you and dinner, but I wanted to see if anybody had any questions, or that was all I had. So thanks, Jan.
Thank you very much. I'll just open it up again to the audience online. If you have any questions, feel free to pop it up in the session chat. Very interesting work. Thank you so much again.
Yeah, I decided to do it this year. I didn't do it last year or the year before. I thought it was time and fair to kind of bring this out, what we're doing.
Especially since it ties into some other research efforts too.
Yeah, I hope so. I seem to be hearing things about that. I'm not sure, but I would hope that this might have some applicability there. And again, the cyber resilience work that's being done and the digital engineering work is just phenomenal. It really is going to help move the yardsticks.
Ms. Judith Bethman is here. She's asking what's the best way to follow up with you.
If you can just forward my information, my contact information, that would be great.
Will do. Thank you.
Anything after this, I'll just send a email to virtually introduce the two of you.
Yeah, that would be fantastic. Thank you. I will tell you there's a huge need, as you can see. Very interested if anybody's out there doing any modeling and simulation related to mission engineering. I think that's a huge gap. And my hands are getting tired doing this on the computer by myself. So if there's a way we could start evolving that would be great. Data analytics is a critical component to this. The data, the way we manage the data, move the data, is a major gap that I see moving forward. So those are two areas that we really could use some tremendous support in. So if anybody out there has anything like that, that would be excellent.
I think you're echoing some of what was said in our keynotes, as well as NAVAIR and some of the Naval DSAT folks are trying to move forward in this area, and they have the Naval Digital Engineering Body of Knowledge. So
yes, yeah, they do, right? Very familiar with the Navy and what they're doing there. So that's fantastic. We've been working mostly with Dahlgren, Naval Surface Warfare Center Dahlgren, on that. But that's great.
We have another comment from Judith. This is the area where we have been working on. She's interested to know how your approach might be done in the approach that they have been developing for R&E. So I think that's where she will probably want to.
And I'm very much aware of the work that she's been doing and where MITRE has been. So that would be an excellent conversation to have.
In your ME certificate, would you care to elaborate a little more on that?
Well, I'm gonna tag Peter Beeling for that. I think he's got the guy with the target on his back. But again, it came out of a need we're seeing out of DoD for some additional training. So we're right now it's lodged firmly, hopefully, in the industrial systems engineering, because again, mission engineering, it requires a systems engineering approach, right? It's not meant to displace it. So it's systems engineering in my mind is sufficient, is necessary but not sufficient to complete that. So we believe it's an evolution of a systems engineering approach. So we're developing that largely. Hopefully in concert with DAU, where there'll be synergy between the content and the coursework we're developing for DAU and for the certificate program. So the idea, you'd be coming out of that certificate program well-versed in the way that mission engineering can be applied, not just to DoD, but we're looking at it, and I don't show it here, but we're looking at it with Department of Homeland Security, we're looking at it with hospitals, we're looking at it with other nations. So there's a host of other applications there, and we felt like a graduate course that would have essentially 5 courses there that would embrace that, but it also would touch and show how systems engineering, digital engineering would play a role and help infuse mission engineering to allow you to do that application. So there are 5 grad courses that we've identified, and we're building out the content for right now. And as you can imagine, they're largely around mission threads and how you derive those and how you break that down. A lot of it is analysis and data and how you manage the data and how you derive the data, and measures, which is what, to me, what it's all about. It's the hardest thing you can do is develop measures or pin somebody down and get them to define for you what the measure is. So
That's right.
It's extraordinarily difficult.
Thank you. And we just have a comment from Peter here saying that the ME certificate is associated with the Masters in Systems Engineering offered by Virginia Tech. And the first course will be an ME course in the spring taught by Jim Moreland.
Right.
Yep.
Yes. Perfect.
And we have another question from Alfred Schenker. What do you think is necessary to enable cross-domain missions and the governance processes to evolve them?
Well, that's a great question. And I, off the top of my head, I would say I'm open to anybody's suggestions. But I think it starts with what we're doing with the training and DAU. And again, we actually started there with 1 course, and we're up to 3. And as I'm working with the Air Force and DARPA and the Marine Corps in this, I see a great deal of, I see a great opportunity where they're all trying to derive the same answers, but they're using a much different terminology. So one of the things we're going to have to address is how we do that. One of the drivers is, I think, acquisition. I mean, nothing will drive it like the money. If you're introducing new technologies, you move forward and you're trying to derive funding for your projects, I think putting it in the mission context is going to be critical, and that'll drive that commonality. Other than that, I think it's going to take time. It's right now we're in hand-to-hand combat where every day is 3 steps forward, 2 steps back. But again, what we're finding with the Air Force and the Marines and DARPA is we're making tremendous inroads. It really has been a really exciting time, and how we're using that to infuse the courses at DAU and make them practical. So the idea is at DAU, we're going to use practical, actual experiences and situations and vignettes and scenarios to help convey those messages. So I think that helps too. I hope that started to answer it. I'm bailing on your question because it's a hard one.
A follow-up from Alfred. What do you think about certifying platforms to participate in missions?
I think that's my view is, I think ultimately, the word certify is gets us into some trouble, I think. We're going to have to develop a different thought process in how we talk about those things. Is we're developing systems now and we're applying, we're defining their military utility across multiple missions right now. Is that a certification? I'm not sure. I'm loath to create an office for mission certification, which is ultimately where the DoD would ultimately probably go. But I'm concerned about that, because if you remember where we started out is we want to be agile, we want to be quick, we want to be responsive. So that's where the rapid testing has really taught us, right? It's that if I can quickly define the mission, the concept, and show testing and your ability to meet those, I've got to eventually hand that off, right, to Big Brother testing at DoD, and that's an area where we're going to have to work on. Again, I know I'm dancing around your question, but these are excellent questions, and I think about them a lot, but I don't have a clear vision for you.
Just commented using the word qualify.
Yeah, maybe that's the okay. So I've worn you down to qualify. So yeah, I think that's important. I think as you look at those portfolios at the A&S level, right, the mission portfolios, and you start creating those buckets, I think qualify starts to make a little more sense, where you could begin to qualify those, right? But you have to really define what your mission web is and how those are integrated into your portfolio, your mission portfolio capabilities, right, at the A&S level, how those systems will drop in and operate. But I think that's where you have to go. And by qualify, what I believe is it's that command and control, it's that JADC2, it's that operating across multiple domains, multiple services, and even so far as interacting with our coalition and partners, coalition forces and partners.
Commented that maybe there is a mission definition that you need to adopt to qualify.
That would be excellent. I think that's an excellent point, and I am entirely open to that. We spend a tremendous amount of time over gnashing our teeth over data, and where do you get it? How do you manage it? Because to me, it's all about the data. And that's a struggle that we continuously have, because it forces you in a position to make some it makes assumptions, and that can lead you down some very, very inexact paths. So I would agree with you absolutely. But that's a much bigger challenge. But you don't cross the Grand Canyon in one leap, right? You got to take baby steps. So.
Well, thank you so much. This was a great discussion and great presentation. We appreciate your hard work, you and your team. And with that, I think I'll be closing the session a couple of minutes early so that you have time to jump back onto the main stage for the closing remarks. Thank you again for all your time and your effort. We appreciate it.
Thank you, guys. Have a great day.
You too.